Yes. Good afternoon to all. Never complain about difficulties in life because the director is always giving the hardest roles to his best actors. Rightly said by great Indian scientist and former President of India, late Dr. APJ Abdul Kalam. I, Dr. Kumudini Ahir, Assistant Professor, Chemistry Department, extend a warm and a hearty welcome to all the faculties and students who have joined us for this national webinar entitled Application of Coordination Compounds in Various Fields. It gives me an immense pleasure to have you join us on this virtual platform organized by Department of Chemistry under the banner of TLE Society's Science and Commerce College. We are here to enlighten ourselves on the topic application of coordination compounds in various fields by our eminent speaker, Dr. Sudheer Lingayat. I would now request Head Department of Chemistry, Dr. Richa Singh, to introduce our guest speaker in order to gear up for this event.
Thank you, Kumudni ma'am. Am I audible now?
Yes, ma'am. Yes, ma'am.
A very good afternoon to one and all present over here. It is my privilege to introduce our honorable guest speaker, Dr. Sudheer Lingayat, for national webinar Applications of Coordination Compounds in Various Fields. He is Associate Professor in Department of Chemistry of Guru Nanak Khalsa College, Matunga. His area of specialization in inorganic chemistry. He is visiting lecturer in Kalina, Mumbai University, in ICT for FY BTech students, in VGTI for MTech Environmental Chemistry students, in MSc Bioanalytical Chemistry and Analytical Chemistry. He conducted inorganic chemistry practicals of MSc Part 1 students at Kalina, Mumbai University. He has teaching experience of 28 years for UG and PG courses. He is co-author of textbooks for FY, SY, and DY in Organic Chemistry, which is published by Shade Publications. He is nominated as a Board of Studies member of Chemistry in University of Mumbai, nominated as subject expert in various colleges by University of Mumbai, and also nominated as member of LIC for PhD recognition in colleges. He has worked as chairman for MSc and PhD courses at NMIMS Mumbai for 4 years. Thank you so much, sir, for
Yes.
accepting our invitation. Thank you so much, sir.
So now I would like to request our guest speaker, sir, Dr. Sudhir Lingayat, to take charge of this e-platform.
Yes, good afternoon, participants. First of all, I thank Kumudini madam and Richa madam for their kind words of introduction, and also it's a great opportunity for me to interact with you people. So, and thank you to Principal and Management and Department of Chemistry of KLE College for giving me this opportunity to talk on certain aspects, applications of coordination compounds. I will not say students because faculties are also there. The basic purpose of selecting this topic is, as we know that when we go for any particular element, when we consider the atoms, when they are unstable, they try to combine with other atoms and thereby they result in the formation of compound. Depending on the attractive force which is present, it may be compound formation by ionic bond, it may be covalent bond or coordinate covalent bond. When it is covalent bond, the electrons which are required for the formation of bond, they are shared equally by combining atoms. So we say that pair is sharing equal responsibility. When we go for coordination compounds, here the bond is there, but the entire electron pair is shared or is donated by particular element which will learn afterward as a ligand. When we go for this coordination compounds, you will come to know, of course, there are a variety of applications of these compounds, and definitely it will not be possible for us to cover everything in this short span of around 50-55 minutes. But whatever is possible in this time span, I'll try to focus on maximum aspects of coordination compounds. And during this expectation, during this discussion, what I'll expect is coordination from you. And of course, though we know that coordinate covalent bond results due to sharing of electron pair from only one species, can I expect you also to interact? What I mean is, I hope you will not only expect me to speak and you only to listen. If you interact, if you add some examples to my discussion, it will be nice. Now, when we go for this coordination compounds, little bit I have told you that basically these are the compounds where metal ions are surrounded by either neutral molecules or negatively charged ions, what are called as ligands. Now, when we go for compounds, we'll see we can divide them, we can classify them into roughly three types. Now here, give me a minute. I'll be sharing the screen with you. Just a minute. Can you see the screen? Is my screen visible?
Yes, sir. Yes, sir.
Yeah,
Yes, sir.
yeah. So when we go for applications of coordination compounds in various fields, as the name suggests, various fields. So it shows that there are number of applications not only restricted to one particular area, but variety. Now, when we go for the salts, we can say that salts like sodium chloride, potassium chloride, they are simple ionic salts where we have got cation and anion. And when we dissolve them in water, these ions are separated and we can check them qualitatively, okay, by using certain specific agents. Now, if you consider potassium chloride, when it is dissolved in water, it gives K plus and Cl minus. And if I consider magnesium chloride MgCl2, it gives us in water Mg2 plus and 2Cl minus. Now, if I fuse KCl with MgCl2, it will result in a compound called as KCl MgCl2 6H2O. It is also called as Kahnlite. Now this compound, it exists in solid state. It is made up of two salts. It is called as a double salt. Now when you will come for complex salt, they also will be made up of two salts. But what is the difference? We'll see. If I consider this KCl MgCl2 6H2O, then when I dissolve it in water, it gives us K plus, Mg2 plus and 2Cl minus. It means when I take something what is called as double salt and dissolve in water, it is not now existing as KCl MgCl2 6H2O, but it separate into its constituent ions. Another example, if I take ferrous sulfate in water, it will give you Fe2 plus sulfate 2 minus. Ammonium sulfate, it will give us ammonium and sulfate anion. But when we take ferrous ammonium sulfate, which is obtained from these two simple salts, it dissolves and gives us Fe2 plus ion, ammonium and sulfate anion. Means it separate into constituent ions. Similar is the case with salt obtained from potassium sulfate, aluminum sulfate, which is also called as potash alum. When I take potassium sulfate dissolved in water, it gives us K plus sulfate 2 minus, aluminum sulfate, aluminum 3 plus, sulfate 2 minus. This potash aluminum sulfate, which is also called as potash alum, when dissolved in water will separate into its constituent ions. We say in chemistry, the salt is losing its identity. The salt is losing its identity. That means it exists only in the crystalline state or solid state. Now when we move to third type, what is called as complex salts or coordination compound, which is our topic of discussion today. Suppose if I take potassium cyanide and ferrous cyanide, then potassium cyanide should give us K plus and Cl minus. Ferrous cyanide should give us Fe2 plus and Cn minus. But the salt obtained from this K3FeCN6, or if I take K4FeCN6, or when we take cobalt ammonium chloride, then when they dissolve in water, see how the ions are produced. From KCl, as we have discussed earlier, we get K plus and Cl minus. MgCl2 gives us Mg2 plus 2Cl minus. But if I go for salt obtained from this KCl and MgCl2 and participants, there are many examples, but this is just a little introduction. Rather than going directly for application, I thought I'll throw some light on certain aspects of coordination compounds before we go directly for applications. So when we get KCl MgCl to 6H2O, what is called as double salt, it loses its identity in solution and separate into K plus Mg2 plus 3Cl minus. Now, if you consider coordination compound, which is obtained from KCN and FeCN2, K4FeCN6. Of course, we won't be discussing in detail IUPAC, but this compound, it is potassium hexacyanoferrate 2. Potassium hexacyanoferrate 2, when dissolved in water, will give us 4K plus and FeCN6 4 minus. Now, what is surprising is it is not double salt. How do we know? It is not producing separately Fe2 plus and Cn minus, but it is just producing K plus and FeCN6 4 minus, which can be confirmed from measurement of electrical conductivity or colligative properties. Similar thing is there with potassium tetracyanonickelate 2, that is K2NiCN4. Rather than giving K plus, nickel 2 plus, Cn minus, it gives us 2K plus and NiCN4 2 minus. So when we go for these salts, now what we know is in double salts, the identity is lost when we prepare their aqueous solution. But in coordination compound, we don't get constituent ions, but we get certain ions, like here you get potassium, okay, and complex ion. In complex ion, we have got what is called as central metal atom or ion bonded to what is called as ligand. Now these ligands may be like Cl minus, Cn minus, Br minus, OH minus, iodide minus, or they may be neutral molecules like water, ammonia, ethylene diamine. So variety of ligands will combine with metal ions to form compounds what are called as coordination compounds. And dear participants, it's really interesting that for a particular metal ion, when ligand is changed, properties change. It may be magnetic property, it may be color, it may be stability, and because of this, they are useful in variety of field. When we go for ferric chloride, if we treat with thiocyanate, that ferric chloride which is yellow colored, it becomes red in color. When we go for cobalt compounds, when they are combined with ammonia, when they are combined with thiocyanate, when they are combined with nitrate ion, chloride ion as ligands, their colors are different, their magnetic properties are different. With some ligands, they are diamagnetics. With some ligand, they are paramagnetic. So, because of this, different magnetic properties, their different color, their different geometries. Okay, these compounds are of interest to the researchers. Now, when we come to the research, now these compounds, because when we go for talking about applications, we will throw some light on their discovery. It's quite interesting to note that in 1597, Libavius, he had prepared compound by adding ammonia to the copper salt. He got their blue colored solution, but it was very difficult to know what is the reason for this. That copper salt is there, you are adding ammonia, and the color, there is a change in color, okay, and it is resulting in some dark blue colored compound. What was the reason for this? It was not known. Then afterward, of course, number of attempts were there by different scientists, but to list the few which are prominent, Dispatch in 1704, he had prepared compound what we know as Prussian blue. It is a pigment and it is also called as artist color, where we have got iron in +2 +3 state. This was compound which was prepared in 1704, but until 1798, that people could not understand the nature of the bond and what are these different types of compounds. In 1798, Tazad, he prepared orange brown compound by addition of ammonia to cobalt chloride. This actually is treated as the first discovery of complex compound because he noticed that these compounds are distinctly different from their constituents. When we talk about double salt, complex salt, now we differentiate. But until Tazad, he tried to understand, yes, cobalt chloride has different property, ammonia has different property, and when I make the compound from this, the compound is having different color and the properties are different. Is ammonia neutralizing HCl there? Is it free to react? Okay, and because of this, certain thoughts which were given, this discovery is thought that yes, it is the important in history of synthesis or discovery of coordination compounds. But the basic pioneer, okay, was Alfred Werner, who was professor in the Institute of Chemistry in the University of Zurich. He prepared the compounds and he thought, yes, the bond between cobalt and ammonia in the compounds which were prepared by Tazat, okay, these compounds are something different. It is really interesting and one of the example of dedication, like we all have heard about structure of benzene and we relate that with the Kekule dream, how he derived the structure from the dream where he saw some snakes are playing. Similar to that, there is a history or story of Alfred Werner, which was told or which is mentioned by his student Pfeiffer, that he said that Werner always used to think about nature of bond between metal and ligand in coordination compound. That what exactly is there, that in this particular compound ammonia is bonded to the cobalt, chloride is also there. When precipitation is there, only chloride is precipitated, but when it is treated with HCl, ammonia is not getting neutralized. So He used to think about that continuously. And it is mentioned by Pieper that Alfred, and one night he was thinking about this bonding, and he slept. He saw something in the dream. He suddenly got up at 2 o'clock in the night, and from 2 o'clock in the night, he started writing about this theory of coordination compound. And it is mentioned by Pieper that next day in the evening at 5 o'clock, he concluded that theory, which in short, in the words of Alfred Werner, even when to judge by the valence number, the combining power of certain atoms is exhausted, they still possess, in most cases, the power of participating further in the construction of complex molecules with the formation of very definite atomic linkages. The possibility of this action is to be traced back to the fact, besides the affinity of bonds designated as principal valencies, still other bonds on the atom called auxiliary, that is residual valencies, may be called into action. Now, when we go for this particular theory, from that, in simplified words, this particular observation is put like that whenever there is a formation of compound, whenever there is formation of compound, the compound can be considered to be consisting of two parts. One is what is called as central metal atom or ion, and other is ligand. Now this central metal atom or ion exhibits two types of combining capacities. One is called as primary or ionizable valence, and another is secondary, what is mentioned here as auxiliary residual valency, which is also called as non-ionizable valency. So when we go for coordination compound, the metal exhibits dual valencies. Like if I say copper sulfate, it is copper 2 plus and sulfate 2 minus. But when I take tetraamine copper 2 chloride, so in this NH3 ligands, they are attached to the copper, there are 4 ligands, and 2 chloride ions, they are attached to the copper. So according to Werner, that metal is exhibiting here dual behavior, dual capacity. One is what is called as due to its oxidation, it is called as primary valence, and another is what is called as secondary valence, which is due to coordination. And this coordination or secondary valence is expressed in terms of what is called as coordination number. And on the basis of this, the further observation or further statement was, due to this coordination number or coordination valence, we can explain isomerism which is exhibited by these different compounds. Now, for principal valence, ionizable valence, it is always satisfied by anions, but secondary valence or what is called as residual or auxiliary valence, it can be satisfied by anions as well as neutral molecules. Now, when we go for these coordination compounds, and as we have heard here, that when we go for any central metal atom or ion in coordination compound, it takes different number of ions, which may be anions or neutral molecules, as ligands. They are bonded to this metal. It is because of these two different capacities. It is because of these two different capacities. Why we call Alfred Werner as father of coordination compounds? Here, I would like to quote one example. It will come in our discussion. The most important coordination compound which comes in application under medicinal field as cisplatin, which is used for cancer therapy. Of course, we'll be discussing that afterward. But why do I mention here this cisplatin? I repeat, when I said isomerism, so isomerism can be explained in terms of secondary valency or what is called as auxiliary valency of central metal atom or ion. And on the basis of this particular observation or this particular statement, we can explain isomerism. What I want to mention here is, because I mentioned cisplatin, what is the reason? In 1844, Pyrone had prepared one compound, that is cisplatin. I repeat, in 1844, Pyrone had prepared one compound. I said one compound because it was cisplatin, but its structure was not elucidated. Okay, it was not confirmed. This structure was confirmed by Alfred Warner in 1893, means almost after 49 years. But this compound, which is now we know it is most important, its significance, its important role was not noticed at all till 1960, when Rosenberg at the University of Michigan, he pointed out that in electrolysis products of platinum mesh electrodes, I repeat, in electrolysis products of platinum mesh electrodes, certain property was observed. And you know what was that property? That these electrolysis products, they were capable of inhibiting cell division. They were capable of inhibiting cell division. And from that, anti-cancer activity of this particular coordination compound was observed. And after that, many compounds of derivatives of platinum, palladium, and different other metals, and cisplatin, it is compound of platinum with chlorine and ammonia, but along with chlorine, even other ligands like bromide, iodide were also tried. Now, after this little, we can say, history and what is coordination compound, now we move to our major part, for which this talk is arranged, applications of coordination compounds. Again, I repeat, I had said that also in the beginning of my talk, there is variety of applications. I'll be covering only few. So you can add their number of applications, and we can make this coordination chemistry much interesting in future by knowing some of the applications in different fields. These applications I have broadly classified into 5 types: qualitative and quantitative analysis. Under only one headline I have considered them. Then use of coordination compounds in metallurgy. Industry is using number of coordination compounds as catalyst, okay, as process modifiers. Biological systems, it is based on coordination compounds. Medicines, medical field, they make use of number of coordination compounds. So slowly we'll go for this. Now when I go for qualitative and quantitative analysis, qualitative analysis is, as we know, to find out what is present. But when we say qualitative, what is present means it must be accurate. Now when we go for qualitative analysis, suppose we have got a solution. I repeat, number of metal ions are studied under qualitative analysis. So even though I have mentioned here nickel, cobalt, or Fe+2, Fe+3, that doesn't mean coordination compounds are useful only for this. Variety of applications are there. When I go for a solution, and if I come across the question that I need to check nickel 2+, is it present or absent? So what I do, I take the solution. To that I add little ammonia and then add few drops of dimethyl glyoxime reagent which is dissolved in alcohol. If it forms scarlet red precipitate, rosy red precipitate, actually it is the complex of nickel with dimethyl glyoxime as a ligand and it has got red color. So this formation of red color precipitate confirms the presence of nickel 2 plus. Suppose we have solution and we need to check presence of cobalt 2 plus. Then we take the solution of cobalt 2 plus. We don't know whether it is present or not. We want to check, we need to confirm. So to this solution, when we add ammonium thiocyanate, it results in the formation of ammonium tetrathiocyanate of cobaltate 2, and this particular coordination compound has blue color. So after adding colorless ammonium thiocyanate to cobalt 2 plus solution, if there is formation of blue color, this indicates the presence of cobalt 2 plus. This also can be confirmed by performing another test using potassium ferricyanide. If you take the solution containing cobalt 2 plus and to that we add potassium ferricyanide, it results in the formation of cobalt hexacyanoferrate 3, which is reddish brown precipitate. When we come across testing of Fe2 plus, Fe3 plus, yes, many solutions are there where you need to check Fe2 plus, Fe3 plus. So suppose if I take solution containing Fe2 plus and to that we add potassium ferricyanide. I repeat, if I take solution containing Fe2 plus and to that I add potassium ferricyanide. Now in potassium ferricyanide, ion is there in +3 state. So this results in the formation of ferric ferrocyanide ion, which is having blue color. If I take solution containing Fe2 plus and to that if I add potassium ferricyanide, it results in the formation of ferric ferrocyanide ion, which will be having blue color. It is also called as Turnbull's blue. Suppose we have solution of Fe3 plus and to that we add potassium ferrocyanide. Now in potassium ferrocyanide, ion is there in +2 state. So this results in again formation of ferric ferrocyanide ion. But this will be more intense blue color. So though both are resulting in blue color, more intense color will be there with this. The reason for that is when I go for test of Fe2 plus with potassium ferricyanide, this solution will also have the compound what is called as ferrous ferrocyanide, which is white PPT. And due to that, it will be having little, or we can say less intense blue color. Now, suppose if I have solution of Fe2 plus and to that I add potassium ferrocyanide. Now both have Fe2 plus, Fe2 plus, there will not be any reaction. Similar thing will be there. If I take Fe3 plus and to that I add potassium ferricyanide, it is both Fe3 plus, Fe3 plus, there will not be any reaction. In qualitative analysis, when we go for group 2 cations and we come across separation of copper 2 plus and cadmium 2 plus from the solution, then to the solution containing copper 2 plus and cadmium 2 plus, when we add ammonia, it results in the formation of two complex ions. It is tetraamine copper 2 ion and tetraamine cadmium 2 ion. Now these two complexes, both are in the solution, both are soluble. Now when we add potassium cyanide, of course please remember, you must have come across this in literature. You may not have been given this reaction because handling of potassium cyanide is too risky, too dangerous. Only skilled chemist can do this. So when you add potassium cyanide, now there is change in the complex formation. Both amino complexes will be converted into cyano complexes. It is tetracyanocuprate 1 ion and tetracyano-cadmiate 2 ion. But now they differ with respect to their stability. This tetracyano copper 1 ion, it is more stable as compared to its cadmium complex. So what is more stable? What is more stable is will not undergo dissociation, and because it is not able to undergo dissociation, even though it dissolves to a very little extent, its concentration will be negligible in the solution as compared to concentration of cadmium to ion. So though both were first ammonical complexes, now both are cyano complexes, their stability is different. Cadmium complex with cyanide ion is less stable, so it will be dissociated to the greater extent, and hence sufficient number of ions will be available in the solution. So when H2S is passed, copper sulfide will not be precipitated, but cadmium sulfide will be precipitated, and that will impart yellow precipitate in the solution. There are number of examples, but we will restrict our example to only these few because we have to go for number of other applications rather than number, whatever is possible. Now, as we know, when we go for analytical chemistry, along with quantitative estimation is also most important part. And when we go for quantitative estimation, many times we come across estimation of metal ions in variety of sample. It may be the experiment where I need to estimate amount of copper 2 plus in the solution. It may be estimation of nickel 2 plus in the solution. It may be magnesium in the sample of milk of magnesia. It may be tablet syrup. Okay. It may be estimation of calcium, maybe estimation of zinc, manganese 2 plus, or number of other metal ions. So when we go for this estimation, it is really interesting that we can carry out number of estimations of different metal ions using EDTA, which is one most important complexing agent, ethylene diamine tetraacetic acid. Of course, please remember, when in quantitative estimation, when we say EDTA, we are using disodium salt of EDTA. The basic reason, pure EDTA is sparingly soluble in water. Its disodium salt is highly soluble in water. So these estimations, like if I go for estimation of copper, I can titrate it directly against EDTA using fast sulfone black as indicator and ammonia as buffer reagent. If I go for nickel, I can use ammonium chloride, ammonium hydroxide for maintaining the pH, and muroxide as indicator. If it is estimation of magnesium, calcium, zinc, we can go for iriochrome black tea as indicator. Now, when we go for complexometric titration, the most interesting part is here there is formation of two different complexes. One is when you take solution of metal ion and to that you add indicator, it forms metal indicator complex, and this is fairly stable. Suppose you don't touch, it will remain there as it is. Like simple example I'll mention here. If I take magnesium 2 plus and to that if I add iriochrome black tea as indicator, then it will form the complex of magnesium with iriochrome black tea indicator. Now this iriochrome black tea indicator, it is blue in color. But when it forms the complex with magnesium, it has got wine red color. Now when I titrate this against EDTA, it's interesting. Now magnesium iriochrome black tea indicator complex, this bond is broken and new bond is formed between magnesium and EDTA. In other words, less stable. I repeat, I said magnesium indicator complex is more stable. But when we come across ADTA, now the stability is relative stability. Our metal ion and ADTA's complex is more stable as compared to metal ADTA and metal indicator. These two complexes, metal indicator is less stable, metal ADTA is more stable. So now the complex will be changing from metal indicator to metal ADTA. Indicator is release free, and that is the end point. So it becomes, in many cases, it becomes easier to find out end point. Moving with this example further, as we know, when we go for estimation of calcium magnesium, we may come across sample of water for testing its hardness. We know that water containing carbonate bicarbonate salts, in addition to calcium magnesium ions, it imparts hardness to the water. What is the meaning of that? When we consider presence of magnesium calcium ions in water, it may result in formation of scales in boilers and other equipments in industries. Not only that, when we are using this water for washing purposes, as we know, soaps are sodium salts of higher fatty acids, because of which they are soluble in water. Now, if calcium magnesium ions are there in water, they replace that sodium. So, sodium salt of higher fatty acids will change to calcium magnesium salts of higher fatty acids, which become insoluble. This prevents lathering action of soap. So, for this particular purpose, we must remove calcium magnesium ions from water, or we must convert them in non-interfering form, what can be called as masking process. Now for that, we must know first what is the amount of this calcium magnesium. Is it up to a certain limit or beyond that tolerable limit? So we estimate this calcium magnesium using ADTA. And what happens when we consider this disodium salt of ADTA? As we all know, it has got 4 donor oxygens, 2 donor nitrogens, so it is hexadentate ligand. So when ADTA forms coordination compound with metal ions, it is chelate. Chelate or chelate is close ring compound, and as we know, this chelation process is proceeding with increase in entropy, so it is more stable, and hence we can accurately determine amount of calcium, magnesium, and hence the extent of hardness of that water sample. And after we know hardness of water sample, it can be masked by adding stoichiometric amount of ADTA to such water sample, whereby the calcium magnesium ions, they form the chelate or chelate with ADTA, and thereby we say they are masked, and this water becomes now useful for washing purpose or in use in boilers in industry, which will not cause scaling of the boilers and other equipments. Now moving to metallurgy part. As we know, what are the applications of metals are there? Like you can go for making wire rod, their alloys, they must be in the pure form, and this purification process is associated with certain reactions. Some of the reactions are based on principles of formation of coordination compound. If I talk about niobium and tantalum, as you all know, because of their similar chemical properties, they are called as chemical twins. And hence, their separation, their isolation is most important, most sensitive process. And that is possible because though they have similar chemical properties, they differ with respect to their hydrolysis of fluorocomplexes. So niobium and tantalum are separated from each other on the basis of their preferential hydrolysis when they are converted into their fluorocomplexes. And we know that this niobium tantalum, they are used in plastic surgery, like when we go for making space makers, because of their inertness they are used in that, or aerospace programs. When we come to extraction of silver and gold, if I consider argentite, which is ore of silver. Then along with silver, it will have other impurities like iron, other metals. So it is treated with dilute sodium cyanide and exposed to air for 24 hours or more than that. So it is aerial oxidation, which converts whatever the silver is present in the ore in the form of sodium dicyanoargentate 1. It is soluble complex. We can also call it as a leaching process. From ore, it is removed out in the soluble form. And when this is treated with zinc, silver from the complex, which is soluble complex, is reduced to metallic silver. Exactly similar process is used for extraction of gold from antiferrous quartz rocks or tailings which are remaining after amalgamation process. Here also it is converted into cyanocomplex, and cyanocomplex is treated with zinc, solid zinc, powdered zinc, where gold is reduced to metallic gold from the complex. When we go for extraction of nickel, pentaldenite ore contains nickel in addition to copper and iron. When it is treated with carbon monoxide vapors at around 330 to 350 Kelvin, nickel present in the ore on exposure to carbon monoxide gets converted to nickel tetracarbonyl, IUPAC tetracarbonyl nickel 0. This in the form of vapor is then subjected to condensation followed by decomposition at higher temperature of 450 to 470 Kelvin. We get pure nickel, and carbon monoxide which is released is then again recycled back for exposure to pentaldenite. So when we go for this particular reactions what we have cited, many more processes are there which are based on principles of coordination chemistry. When we go for electroplating, electrocoating, you know it is the most important part, because coating is not only for decorative purpose. It may be for imparting surface hardness. It may be for easing the process of cleaning. It may be for increasing corrosion resistance. And hence, when we go for electroplating, the electrolyte which is used, basically it is of the metal which is to be coated on the base metal. So this electrolyte, it should be such that it will have higher solubility, it will have good conductivity, it should have resistance towards oxidation, reduction and hydrolysis, so that when it is coated or plated, the coating will be smooth and uniform. When metals like platinum, gold, silver, copper, nickel, chromium, they are plated on base metals. If we take chloroplatinic acid, it is electrolyte bath for coating of platinum. When we go for gold, we have potassium dicyanoorate 1 or potassium tetracyanoorate 3. If we go for silver, electrolyte what is used is potassium dicyanoargentate 1. So, like that, we have got copper. When we go for chromium, as it is common example, like you know that when we have got stainless steel, for making it more durable or to make it to withstand with higher pressure or regular tear and wear, it is coated with chromium. So chrome plated steel, it is the most common example. Similarly, when we go for coating of platinum on titanium, it is used in fuel cells and many electronic devices. So this particular process, what we call it as electroplating, basically it is using coordination compounds because their solubility is limited. So when we go for process of electroplating, if you want smooth uniform coating, then the ions which are coated, they should be available in the electrolyte bath at particular specific speed, and that is possible when we go for using these complex compounds. In industry, as we all know, the use of catalyst is most important because it helps us to carry out a particular reaction at much higher speed, Okay, you know now even catalysts are selective catalysts. They help us to carry out reactions at lower temperature. Okay, they help us to carry out the process in such a way that the process becomes more economical. Now, many examples are there. Just to cite a few, when we go for hydrogenation of alkenes, it can be carried out easily by using Wilkinson catalyst, which is the coordination compound of rhodium with chlorine, that is chloride and triphenyl phosphine as a ligand. Everybody has heard about polymerization of olefin, where we get high density polyethylene, low density polyethylene, but HDPE, high density polyethylene. It was the process became more efficient after discovery of what is called as mixture of catalyst of titanium chloride and triethyl aluminum. This catalyst was prepared and used and demonstrated by Ziegler and Natta. And this discovery was so important that they were awarded Nobel Prize in 1963 for this particular process. Basically, it helped in polymerization of alkenes. When we go for Rowland catalyst, which is the metal carbonyl of cobalt, this catalyst is most useful in converting alkene into aldehydes, which are then further oxidized to esters and acids. So this process is catalyzed by using coordination compound of cobalt. Another important part is getting hydrogen gas from water gas. Water gas is mixture of carbon monoxide and H2. So carbon monoxide and H2, from that hydrogen is produced. That reaction is called as water gas shift reaction. This reaction is catalyzed by iron and ruthenium carbonyls, rhodium iodo-carbonyls. So this particular reaction was catalyzed by this carbonyls, which are also coordination compounds. Another best example to cite in our food preservation, when you go for freshly prepared fruit juice, fresh fruits, green vegetables which contain vitamin C, when we keep them for longer time, they are spoiled. Basically, the reason for that is presence of certain metal ions which catalyze atmospheric oxidation. So even they are present in trace amount, we can say in ppm, they spoil these eatables. But if we sprinkle little amount of masking agent like EDTA, it forms chelate with these metal ions, and thereby this spoiling of food can be prevented. Coming back to, not back, moving ahead with our own biological system. As we all know, we can't forget hemoglobin. You know what is the role of hemoglobin, and as we know, especially in this pandemic, everybody knows SpO2, oxygen carrying capacity, oxygen level. So the most important part of carrying oxygen from lungs to the different parts of the body and CO2 back from different parts to the lungs, this function is carried out by hemoglobin. And hemoglobin, it is coordination compound of iron 2 with porphyrin as the ligand. Cyanocobalamin, you know, vitamin B12, vitamin having metal ion as cobalt. Again, it is cobalt with porphyrin ring, and this particular vitamin, it is water soluble but much stable to heat. It is important, which we come to know from its deficiency, that if it is deficient, it will cause anemia, inflammation of tongue and mouth. When we go for from living organisms, from V to plant, we know that chlorophyll, it is coordination compound. Here you have got magnesium, which is coordinated with porphyrin ring. It helps in process of what is called as photosynthesis. Now coming to the most important part, because we are moving towards our end of our lecture, it is most important part, medicinal field. And if you remember, I had mentioned that in between cisplatin, if you remember, this compound was prepared long back in 1844 in 1844 by Pyrone. But because the structure was not known, structure was elucidated by Alfred, that is Alfred Warner. But only after 1960, Rosenberg, after studying its activity of inhibiting the cell division, its activity in preventing cancerous cell, it was known. And in this particular medicine, cis form, it exists in cis and trans form. This particular medicine is able to cure variety of cancers like cancers in ovaries, testes, and solid tumors in head and neck. Basically, it is because of its capacity to arrest the growth of, that is, cancerous DNA. We all have heard about lead poisoning. Lead poisoning, it may be due to inhaling lead vapors in the air. Of course, everybody has heard about now non-leaded petrol. Otherwise, when it was leaded petrol, this problem was severe. Otherwise, lead can enter in our body. It may be through air what we inhale, it may be water what we drink, it may be food products what we eat. So it is really dangerous, because if lead enters in our body, it combines with different organisms, and thereby it is dangerous for our health. How it is treated? It is called as chelate therapy. Calcium EDTA injection, when it is given, calcium EDTA complex is stable, but it is less stable as compared to lead EDTA. So when calcium EDTA is injected, lead which is entered in our body because of lead poisoning, lead will combine with enzyme. Lead enzyme complex will be, lead will combine with EDTA, lead will combine with EDTA, and it will be then excreted through urine. You can see here, this is X-ray of patient whose bones are affected because of lead poisoning. This shows what is called as severity. When I mention about cisplatin, which is compound of platinum, there is another compound of gold, which is used in the treatment of rheumatoid arthritis. Coming back to last example, last, of course, not last, it is last in our discussion, phthalocyanin blue. Like that, it is complex of copper. Like that, many such compounds are there which are used in industry as dyes or pigments. Coordination compounds, they find a variety of applications. It is very difficult to cite only few in short time interval, but I am really thankful to KLE College and their management for giving me this opportunity and bringing out to all the participants to their notice. Of course, most of the applications, you know it, but I thought I'll cite these few examples to highlight the importance of coordination compounds. So most of you who are in academics can move ahead. I desire you should carry out your research activities and prepare many such compounds and increase the list of these applications to infinity. Thank you all. Yes,
Yes,
Kumudini
sir.
madam.
Yes,
Yes,
sir. Yes, sir. So
yeah.
that was really a very indeed informative session. Now I would like to call upon Dr. Sulochana Bhalekar for assisting in the question and answer session.
Yes, yes,
Yes.
yes, yes. If any question is there,
Thank you. Yes, thank you so much, sir, for enlightening us with your great knowledge. I, Dr. Sulochana Balekar, would like to proceed further with question answer session. Sir, there is one question from one of our student, Bharti
yeah,
Gupta.
yeah.
Can cisplatin prevent blood cancer also?
Blood cancer. See,
Yes, sir.
now see basically,
Cisplatin.
yeah. Now see basically, it is related to DNA. So wherever it is DNA part, what it will do is, because of the closer dimensions of cancerous DNA and cisplatin, it will combine with that guanine part and it will arrest the growth. Okay, but now what is observed is, I'll tell you, though we say it is most important, along with that cisplatin, what is observed is when this medicine is used, basically it is little dangerous for certain parts like kidney, and hence the different derivatives of cisplatin, what is also called as carbonatoplatin, okay, is used in place of that chloride as a ligand. Okay, so basically because of this drawback, the certain applications of this are limited. Okay, because mechanism for that is arresting the growth of that DNA cell. Okay, so only that much I can tell here.
Yes, sir,
Yeah,
one more question from Kavita Deshmukh.
yeah,
Sir, EDTA is harmful for health. Can
yeah.
we still use it for food preservation directly?
No,
If
like
no,
say,
then
yeah.
do we modify it a bit and then use it?
No, see here, when we use it in small ultimately what is the concentration? Not even 1%. It is too less. And then second thing, what happens when we consider, like I'll tell you specifically, when we inject, even it is used
Screenshot.
as a treatment. Yeah. So it is used in very small amount. So what happens when we have got these metal ions? I'll repeat. Why that spoilage is there? Because the presence of these metal ions. So as compared to eating spoiled food, it is better to use this chelating agent, and when it is sprinkled, it is combining with this metal ions, so now it is no more free. Am I correct? Yes or no?
Yes, sir. Yes, sir.
It is in the form of complex now. Yes.
Any other questions from participants? Dear students and respected faculties, you can directly ask even
Yeah, they
unmute
can.
yourself and yes.
Okay, I guess there are no questions from the audience, so let us proceed with the next. Sir, actually, I would like to convey regards on behalf of Principal Sir, Dr. G.D. Giri. Due to some prior commitments, our Principal Sir was not able to join this session.
No, no problem, no problem, no problem.
So, dear audience, the feedback link is already posted in the chat box. Please give your valuable suggestions by clicking on the link. I would now like to call upon Assistant Professor, Professor Ankita Dubey, to propose the vote of thanks.
Am I audible to you, ma'am?
Yes, yes.
A very good afternoon to all of you. I'm Ankita Dubey, faculty of KLE College, Mumbai. Would like to propose a vote of thanks on behalf of the Department of Chemistry. First and foremost, I would like to thank our eminent guest speaker, Dr. Sudheer Lingayat sir, for accepting our invitation and enlightening our student participants with a great knowledge. As Sir addressed, the coordination chemistry is paramount and it is an interdisciplinary topic. Sir, definitely our students will seek this topic as a career subject. Once again, I thank you, sir, for your valuable presence and guidance. Further, I would like to thank the management of KLE Karamboli and our honorable principal, sir, Dr. J.D. Giri, for their continuous support and encouragement. I want to thank the head of department, Dr. Richa Singh, for their guidance and support. I would like to extend my thanks to the technical team member, Assistant Professor Neha Pandare, and organizing team member, Dr. Kumudini Yahar and Sulochana Bhalekar, for their continuous efforts and cooperation. Last but not the least, I would like to thank all the participants and my dear students for their active participation throughout the session. Once again, I thank you all and wish you have a beautiful day ahead. Thank you. I kindly request all the participants to give their valuable feedback, and the link is given on the chat box.
Thank you so much, sir.
Thank you.
It was
Thank
Thank
you
you.
it
so
was
much.
really great
Yes.
session,
Yes.
sir.
Thank you. Thank you very much. Yes. Thank you for giving this opportunity. It's really great to interact with such people. Yes. Nice. Thank you very much.
Thank you
Yeah.
so much, sir. So
Yeah.
you really
Thank
Yeah.
you, sir.
Yeah.
give insight of the topic. Thank you, sir. So with the sir's permission, I conclude this session. Thank you all and have a great day.
Yes.
Students, kindly
Can I
fill
leave?
feedback
Yes.
form. Yes,
I
sir.
can leave
Yes,
now,
sir. You
madam.
can.
Kumudini madam, I
Yes,
can
sir.
leave
Yes,
now.
sir. Sure.
Yes.
Thank you.
Thank.
Thank you so much, sir.
Departmental faculties, please wait. Don't leave the meeting.
Ma'am, have you sent it the feedback form link?
Yes, I have dropped it in the chat box. You are not there? I'll paste it again if you want.
Yes, ma'am. Sure, ma'am.
Just check your chat box. Just a minute. Just a second. Hold on.
Yeah, ma'am. Sure.
There you can see it.
Yes, ma'am.
Yeah.